Namaste and welcome to everyone watching this video. I'm Karthik Jha and today we will be discussing a very interesting problem. I have started a series in which I'll be discussing some interesting problems or interesting NTSE practice problems because NTSE is approaching. So we will be looking into some problems and then I will give you questions from previous year papers which involve same kind of approach or same kind of concept. So without wasting much time, let us look into the question. It was a very comprehensive question. I have formulated it in the form of a diagram, but you should try solving it in a comprehensive manner. So the problem said that you have a larger circle, let's say C1, whose radius was given as 14 centimeter, and you have two other circles, two smaller circles, namely C2 and C3, which are congruent and which are drawn on the diameter of the of C1. Okay, and these two circles have the radius of the bigger circle as their diameter. Okay, now you have the fourth circle, that is C4, which touches all these three circles, C1, C2 and C3. It touches C2 and C3 externally and C1 internally. So now you are asked to find the radius of circle C4. By the way, this question has been repeatedly asked in KVPY, NTSE Stage 1 of many states and NTSE Stage 2 as well. So give this problem a try, and once you are ready with the solution, keep watching the video to check out your solution. So as I have repeatedly told you again and again, that the key to any geometry problem lies in understanding the diagram and comprehensively deducing it into mathematical form. Okay, articulating a complex English into a simple mathematical formulation. So what we will assume is this is the center of C4 and this is the center of C2. This is the center of C1, that is O. Okay, and the radius, the required radius, let us assume is R. Okay, now you know that if you know that the radius of the largest circle is 14, so from here to here it is 14. Okay, and from here to here it is R. So can I conclude that this particular length, side length, is 14 minus R? And by the way, why am I finding all this? Because I propose that if you join these three centers of these three different circles, you will get a right angle triangle, and this is the right angle. And I think it's very easy to prove that this is a right angle, and I want you all to give this a try and prove that this is a right angle. You should also prove that this is a straight line. This is a straight line. How will you do that? Just draw a tangent. Okay, so from the center of the circle to this common tangent, there will be 90 degree. They both will form 90 degree at the point of contact. Same will go with circle 4 as well, and thus as both of them will add up to 180 degree, we can conclude that this is a straight line because they form a straight line angle. Okay, so that is quite easy. And now if this particular triangle is right angled here, if we know all the three sides, we can apply Pythagoras. So I am planning to apply Pythagoras, and for that I want to find the three sides. I found one side, that is 14 minus R. Okay, which was quite easy. Okay, and then I found this, and I think finding 14 minus R is the biggest catch here, and you must note that down. Okay, so this particular length is R, this particular length is 7, so this will be 7 plus R, because the radius of C2 is 7 centimeter. I told the diameter of the radius of the bigger circle is the diameter of the smaller circle, that is C2. So the radius would be 7 centimeter. That's not tough to find. And then this is 7 centimeter. So the hypotenuse is 7 plus R centimeter. The two base lengths are 7 centimeter and 14 minus R centimeter. Okay, now we will apply the Pythagoras theorem, the standard assumptions that I already made. R is the radius, and then we apply the Pythagoras theorem. 14 minus r whole square plus 7 square is equal to 7 plus r whole square. Now we open up all the brackets and then try to simplify this expression to get the value of r, which is r is equal to 14 by 3 centimeter, or in other words it's 4.67 centimeter. So that's it. So this, I think, was a pretty interesting and a logical problem which requires a lot of time to solve, but as an NTSE you get only 1.2 minutes for each problem, and more than 1.5 minutes you cannot spend on any problem. So I want you to try the other problem yourself and try to be very brief and try to be very fast in your approach. So this is your problem. Two circles, both of radii a, touch each other and each of them touches internally a circle of radius 2a. Then the radius of the circle which touches all the three circles is. Now the answer to this question will be available in the comment section, but I will upload it after a day, and I want you all to approach this problem before looking at the solution. You should also write down the explanation. So this is a fun problem. Try this out yourself. It will involve the same approach that we did in the previous question and almost the same figure as well. So try out this problem yourself. Thank you. If you like this video, please do like, share and subscribe, and to stay updated please press the bell icon so that you can get the latest update from RKI. Stay safe, stay healthy. Thank you.